AB Calculus, section 5.2, page 2. All right, expanding this out and looking at what a Riemann sum is. A Riemann sum is this summation right here. I equals 1 to n, so we're still counting, and this delta sub I of x, that is representing the width of each of the individual rectangles. And this f of w sub I, this is representing the height of each individual rectangle. Both of these vary, they change. Nothing here is remaining constant. All together, multiplying each of the widths times the corresponding heights, this estimates area under a curve. Oh my gosh, I didn't realize it was up too high, so there we go. All right, let's take a look at this example. I want you to find the Riemann sum for this function, f of x is 1 over x plus 2, for x between -1 and 3, using this partition. I'm not going to read all of that to you, and these w values right here. All right, these, the x values, this partition right here, those are the x values that will determine the widths of the rectangle. It's the x values that will determine the width of the rectangles. This w values, they're labeled as w's, but they are x coordinates. These are x values that will be used to determine the heights. All right, let's sketch a graph of f of x is 1 over x plus 2. 1 over x plus 2 has a vertical asymptote at x equals -2. We're not interested in that because this graph, the area we're looking for is between 1 and 3, or excuse me, -1 and 3. So let's put -1 out here, which means then that 1 is there, 2, 3. All right, and then let's just plug in some points here. When we put a -1 in here, we will end up with 1. Let's put that way up here. All right, plugging an x in, plugging a 0 in gives us half, which is right there. Plugging a 1 in, a third, about here. Plugging a 2 in gives us a fourth, so about there. A 3 in, a fifth, about here. So when we sketch this graph in, we see something like that. All right, now use these x values to figure out where those rectangles are going to begin and end. So x of 0 is at -1. That's x of 0. And that's where we're going to start. x sub 1 is at negative 0.25, so right about there. X sub 2 is at 0. So what this is telling us is that's the first section. There's the second section. Third one at a half. Fourth one, 1.25. Fifth is at 2. Sixth, 2 1/4. Seventh at 2.75. And the eighth at 3. Three, 4, 5, 6, 7, 8. All right, notice the number of sections here, which will be the number of rectangles, has to match this subscript here and here. There's your sections, but those are not rectangles. We need to determine the heights. So we go back. This first section, its height is determined by negative 0.75. So let's find negative 0.75 right about here. Line that up to where it hits the function. That's the height of the first rectangle. Here's the first rectangle. W sub 2 is at 0 right there. Have that one already. That's the height of the second rectangle. W sub 3, 0.25. All right, 0.25. Oh, that's right in the middle. That's a midpoint height. That's an MRAM right there for that one rectangle. There's the third rectangle. Fourth one is using 1. Now that's not a midpoint. That's not a left or right. That's just some arbitrary point in between. Fourth rectangle. Fifth is by using 1.5. Sixth by using a 2. Seventh by using 2.5. These are hard to see down here because the curve's getting pretty flat. And the eighth one uses a 3. Okay, notice on this one I did shade the actual rectangles, not the actual underneath the curve, because a Riemann sum estimates that area, but it is actually area under the curve, but it is actually finding the area of the rectangles. So when we write this out then, to find that Riemann sum, it is exactly, all right, width of the first rectangle from -1 to -0.25, that is 0.75, times the height of the first rectangle is where -0.75 is plugged into the function. So 1 over -0.75 plus 2. Second rectangle is 0.25 wide, and its height is determined by where 0 is plugged into the function. Third rectangle is 0.5 wide, times its height is where 0.25 was plugged into the function. Fourth rectangle, it is 0.75 wide, and its height is determined by where 1 was plugged into the function. 1, 2, 3, 4. Fifth rectangle is from 1.25 to 2. That's 0.75 wide. Height was at, if you forget to mark it down here like I did, you can go back up here and check. 1.5. 1 over 1.5 plus a 2. Sixth rectangle is 0.25 wide. Height was where 2 is. Seventh rectangle, 0.5 wide, height by 2.5. And last rectangle is 0.25 wide and a height determined by 3. When you enter all of this into your calculator, you will get that Riemann sum of 1.635119048. Please type this up into your calculator. Make sure you can come up with this number. I will show you this though. I would type this in just a little bit easier. I would not use any parentheses here. Can you add negative 0.75 plus 2 in your head? Yes, that's 1.25. And then just multiply this 0.75 up to the numerator of that. So I would do 0.75 divided by that, 1.25, plus. And then the next one, 0.25, because that's coming to the numerator, divided by 2, plus 0.5 divided by 2.25, etc. I'm not going to go through and type all of these in for you. You can do that. You can do that, but make sure you can come up with 1.635119048. Thank you very much. Have a nice afternoon.